Dear learners, welcome to this session on correlation analysis. Correlation analysis is a basic statistical tool that empowers researchers to investigate relationship between variables in a market research context. A thorough understanding of correlation and its limitation is important for effective data interpretation and informed decision making. In this session, we will discuss correlation analysis and its applications in marketing research. We will explore the fundamental concepts of correlation, its function, and its practical application through real-world examples. The learning outcomes of this session are explain how correlation coefficient measures the strength and direction of relationship between two variables, then recognize situations where correlation analysis is appropriate, then interpret the strength and direction of associations based on correlation coefficient values, then describe the steps of hypothesis testing for the significance of the correlation coefficient, and appreciate the value of correlation analysis in uncovering potential relationship within data. So, correlation analysis is used to determine the degree of relationship between two sets of data. For example, what relationship exists between the sales of product A and product B, or how does the advertising expenses relate to other promotional expenses? Particularly, every data set with two or more variables can be used to apply correlation analysis. However, it is important to use caution and the cautious approach while looking for misleading or absurd correlations that may occur by chance between totally unrelated variables. For example, consider the relationship between mango sales and air conditioner sales in India. It might seem like a correlation exists. When mango sales are high, air conditioner sales also tend to be high. However, the underlying reason is likely the summer season. During the summer months, mangoes are in abundance and the hot weather drives up demand for air conditioners. So, a researcher must be cautious about drawing conclusions based solely on the values of the correlations. It is important to carefully examine the underlying factors and relationships. So, we can say that correlation studies examine naturally occurring relationships between variables. In contrast to controlled experiments where researchers manipulate variables to observe their effects, correlation studies focus on identifying the direction and strength of association without establishing causation. Consider researching the relationship between study hours and exam scores. Exam performance is naturally correlated with variations in study hours, as study hours are not manipulated in this context. Similarly, height and weight often demonstrate a positive correlation, increasing together in a population. However, this co-occurrence does not imply that changes in height directly cause weight gain or vice versa. So, let us explain the characteristics of relationship between variables with an example. For example, we may have figures on advertisement expenditure, say X, and the sales, say Y, for a firm for that last 10 years as shown in table 1. So, in first column the years are shown, in second column the advertisement expenditure in 1000 rupees X is given, and in the third column sales in 1000 in rupees Y are given. So, for the advertisement from year 2015 to 24 are given as 5, 10, 15, 20, 20, 30, 40, 50, 50, 50, all these are in the thousands of rupees. Similarly, the sales are given as 200, 210, 250, 300, 400, 450, 500, 600, 650 and 700 in thousands of rupees. So, as a first step, When this data is plotted on a graph, we obtain a scatter diagram as shown in figure 1. You can see from the scatter diagram that the power of scatter diagram lies in their ability to reveal patterns between variables. By looking at the distribution of data points, we can identify different types of relationships. Basically, a scatter diagram gives two very useful types of information. First, we can observe patterns between variables that indicate whether the variables are related. Secondly, we can determine the types of relationship that exist if the variables are related, such as linear or nonlinear relationship. Correlation examines whether an association exists between the two variables, and if it does, then to what extent. So, various patterns may be seen in the scatter diagram, and figure 2 displays a few common patterns that illustrate various correlations between two variables. When two variables have a positive correlation, it means that when one variable's value increases, the other variable values also tends to increase, as shown in figure 2a. Here data points show an upward trend. On the other hand, a negative correlation indicates that the value of the second variable tends to decrease when the value of the first variable increases, as shown in figure 2b. Here data points show a downward trend. In the absence of a correlation, the changes in one variable exhibit no influence on the other variable, as shown in figure 2c. There is no clear trend or direction in that data points. Finally, there is a non-linear correlation when there is a relationship between variables, but the relationship is not linear or straight, as shown in figure 2d. So, we will next explore how to precisely quantify the relationship between two variables using statistical tools called the correlation coefficient. The correlation coefficient measures the degree of association between two variables x and y, and the Carl Pearson's formula for correlation coefficient is given as R is equal to summation of x y divided by n sigma x sigma y, or in other terms this formula can be represented as R is equal to summation of x y divided by under root summation of x square multiplied by summation of y square, where R is the correlation coefficient, sigma s shows the standard deviation of data set x, sigma y the standard deviation for data set y, x bar mean of data set x, and y bar is the mean of data set y, and n denotes the number of data points. So, let us go back to the example of advertising expenditure and sales data for a company over a 10 years period that we discussed earlier in the case of the scatter diagram plot. The data is given in table 1. We will now calculate the correlation coefficients between these two variables by using Pearson's correlation coefficient formula. The calculations for this analysis are given in detail in table 2. Here in first column the year is shown, in second column the advertisement expenditure, third column sales in thousand, and in the fourth column the x, that is x minus x bar, and then the y is equal to y minus y bar. Then the next column shows the square of x and x square of y, and in the last column the multiplication of x and y are given. And so from this data point the average of x is given as 29, as 290 divided by 10, and the average of y is given as 426, the 4260 divided by 10. Then we have calculated x minus x bar, we have calculated y minus y bar, x square, y square, and xy. All these values are given in table 2. So, by putting this value in the formula, R is equal to summation of xy divided by under root summation of x square and under root summation of y square, we get the value of 0.976. This value of R, that means the 0.976 indicates a high degree of association between the variables x and y. For this particular problem, it indicates that an increase in advertisement expenditure is likely to yield higher sales. From this, the coefficient of R, we can get the strength of the relationship. The strength or degree of relationship between two variables is measured by calculating the correlation coefficient, which is denoted by R. Now, it is important to note that the correlation coefficient R is a dimensionless number whose numerical values lies between +1 and -1. Positive values of R indicates a positive or direct correlation between the two variables x and y. That means as x increases, y will also increase, or as x decreases, y will also decrease. Negative values of R indicates negative or inverse correlation, thereby meaning that an increase in one variable results in a decrease in the value of the other variable. A zero correlation means that there is no association between the two variables. You can revisit figure 2, which shows a number of scatter plots with corresponding values for the correlation coefficient R. Now, once the correlation coefficient has been calculated from sample data, one is normally interested in determining the existence of an association between the variables or the degree of confidence with which such an association can be asserted. Hypothesis testing provides a statistical method to answer this question. Let us discuss the steps of hypothesis testing. So, as in step 1, we said the null and alternative hypothesis. So, here the null hypothesis can be stated as there exists no correlation between the advertisement expenditure and sales, and it can be represented as H sub 0 such that R is equal to 0, meaning that the correlation between advertisement and sales is not significantly different from 0. The null hypothesis reflects the initial assumption that there is no relationship between advertisement and sales, as we have seen earlier. Unless and until there is no strong evidence for differing the assumption, null hypothesis cannot be rejected. And the alternative hypothesis can be stated here as there is correlation between the advertisement expenditure and sales, and it can be denoted as H sub 1 such that R is not equal to 0. In the given case, it is a two-tailed test, as the correlation can be positive or negative. In step 2, we have to determine the appropriate statistical test. The test statistic commonly used for correlation is the T statistics, and it is calculated using the formula as T is equal to R divided by under root 1 minus R square multiplied by n minus 2, where R is the correlation coefficient and n is the sample size. In step 3, we have to set the level of significance. The level of significance alpha is given 0.05. In other words, the probability of type 1 error should not exceed 0.05. In step 4, we have to define a critical value that separates the acceptance and rejection region. If the computed value of the test statistics falls in the acceptance region, the null hypothesis is accepted, otherwise it is rejected. At the given level of significance, alpha is equal to 0.05, and for two-tailed it is 0.025, and the degree of freedom n minus 2, that means 10 minus 2 is equal to 8. The tabular t value from table 3 is plus minus 2.306. It means if the computed test statistic t is between plus minus 2.306, the decision is to accept the null hypothesis, and if the computed test statistic t is outside plus minus 2.306, the decision is to reject the null hypothesis and accept the alternative hypothesis. So, the collected sample data is given in table 1, and we can get the value of t by putting this value in the formula. T is equal to R divided by 1 under root 1 minus R square n minus 2. So, by putting these values of R as 0.976 and the value of n is 10, so n minus 2 is equal to 8. So, by putting this value, we get the value of t as 2.57. So, at 95% confidence level and 8 degree of freedom, the critical value obtained from the t distribution table is plus minus 2.306. However, the observed value of t is calculated as 2.57, which is higher than the tabulated value of plus minus 2.306 and falls in the rejection region. Hence, the statistical conclusion is to reject the null hypothesis and accept the alternative hypothesis. So, on the basis of hypothesis testing, it can be concluded that there is significant difference in the advertisement expenditure and sales. So, the null hypothesis that is stated as there is no relationship between advertisement and sales is rejected, as there was strong evidence to support the relationship, and an alternative hypothesis was accepted that is stated as there is a significant relationship between advertisement and sales based on the findings. Here are some professional managerial decisions that we can consider. So, the strong correlation between advertising expenditure and sales often leads to the assumption that a significant portion of the marketing budget should be allocated to advertising. Even when the observed relationship is evident and statistically significant, it is important to avoid drawing conclusion about cause and effect based only on correlation. Correlation does not equate to causation. There is a possibility that other variables such as product quality, economic condition or competitor actions are influencing sales figure as well. A comprehensive analysis that considers multiple factors is necessary to accurately determine the true impact of advertising on sales and to make informed decisions about marketing resource allocation. Now, let us see the key considerations in correlation analysis. So, one cannot infer causation from correlation. A relationship between two variables does not imply that one causes the other. Second, misleading correlations, purely coincidental relationship can occur by chance or the influence of the other factors. Then, third consideration is to verify the validity of the correlation and prevent the understandings, that means the misunderstandings. One must exercise critically thinking for rational decisions. When it comes to correlation analysis, examine the results closely to make sure they are reliable. Now, let us see some practical applications of correlations. So, one is the correlation analysis is used as a starting point for selecting useful independent variables for regression analysis. It is also used in factor analysis, wherein attempts are made to resolve a large set of measured variables in terms of relatively few new variables known as factors. The results could be useful in the following three ways. One, to reveal the underlying or latent factors that determine the relationship between the observed data. Second, to make evident relationship between data that had been observed or obscured before such analysis. And three, to provide a classification scheme when data is scored on various rating scales have to be grouped together. Another major application of correlation is in forecasting with the help of time series models. In time series forecasting, correlation, particularly autocorrelation, is used to analyze the patterns and dependencies within data over time, enabling the creation of accurate prediction models. So, now we can conclude that the correlation analysis is a valuable tool for informed decisions. When interpreted with caution and awareness of its limitations, correlation analysis becomes a valuable tool for data exploration and decision making. Then it can be used as for unveiling the patterns. It helps us identify underlying patterns within data, guiding further investigation into potential cause and effect relationship. Then it provides the data-driven insight. By leveraging correlation analysis, researchers can make informed decisions based on deeper understanding of the relationship between variables within their data sets. So, in this session, we have explained how correlation coefficients measure the strength and direction of relationship between two variables. We appreciated situations where correlation analysis is appropriate. Then we interpreted the strength and direction of association based on correlation coefficient analysis. Then appreciated the value of correlation analysis in uncovering potential relationship within data, and describe the steps of hypothesis testing for the significance of the correlation coefficient. So now you can check your progress by answering these questions. So the first question is, which of the following statements about correlation analysis is true? Option A, it can only be applied to data sets with two variables. B, it is always appropriate to interpret a correlation as a causal relationship. C, it is useful for identifying patterns and trends in data. Option D, it requires manipulating one variable to observe its effects on another. The question 2 is, a researcher finds positive correlation between study hours and exam scores. Can we conclude that studying more hours causes high score? Option A, yes, definitely. B, no, correlation does not imply causation. C, maybe, it depends on the specific subject. D, the answer depends on the age of the students. The question 3 is, a scatter plot shows a curved pattern. What type of correlation does this indicate? Option A, positive correlation. B, negative correlation. C, non-linear correlation. D, it is impossible to determine correlation from this information. Question 4, the range of values for the correlation coefficient is option A, 0 to +1 only. B, -1 to +1. C, 0 to infinity, and D, -infinity to +infinity. And the fifth question is, what does a positive value of the correlation coefficient signifies? Option A, no relationship between the variables. B, the variables move in opposite direction. C, the variables move in the same direction. So with this we end this session. Thank you. Happy learning.